had a node, say n, and we did add first and add last, right?
What?
And we did add first and add last. At first we insert this node at the beginning, and therefore make the node in blue the head, right? And at last we take the node and put it at the end, correct? And the blue guy will become the tail. Now, I want to take something more complicated. Let's say this is my list L, okay, my linked list L, and I have numbers here like, okay? And somebody tells me insert node, say 14, and I want that node to be inserted in a sorted manner. Like, clear? So, I shouldn't put this guy at the bottom, sorry, at the end, or at the beginning. This guy should be inserted wherever it's supposed to, right? So visually we realize that we should break this link and somehow connect this guy here and connect this guy here. And therefore our stuff should be ready, right? Is that clear? Yep. Yes? It should be inserted there by breaking the link and making that connection. Okay? How do we do that? That's the problem. Okay? So what are the possible scenarios? One scenario is that I have to insert here, right? Another scenario is that I have to put it at the beginning, right? Maybe the number I have to insert maybe is 6, so it should be here. Maybe the number I have to insert is 8, should be at the end. Or maybe the linked list is even empty, right? So there are 4 possible scenarios, right? Some of them might be combined into one, and we're going to see that. So what would be your first idea for solving these guys?
You're assuming that the linked list is already in order.
Correct. Okay. So if we are going to create a method called add sort that will take any node and add it into the list and should remain the list sorted. Correct? So if you just use this method add sorted all the time, your linked list should be sorted always. Right? If you start mixing add first and add last, you might mess it up. Is that clear?
Yeah.
So how do we manage this?
I guess you can create like a temp, and then you start traversing the list, and every time you do, you check the temp's current data and also the next data, and do some.
You're trying to predict a problem already, right? You already saw the problem. Okay. So let's start by doing the simplest thing, and then let's see if we can combine it. Step number 1 would be, what if list is empty? If this is empty, we can do at first. Forget about it. Right? Or at last. It doesn't really matter. Right? Oh. Okay, so that's something. Okay, for linked list. This is at last. Okay, no, it's fine. It's fine. Okay. So this will be simple, right? I have to do at first, right?
Yep.
Under what situation shall I do at first as well?
If the first number is the same as
Same or smaller?
or smaller.
Right?
Right.
Does that make sense?
Yep.
If the number is the same or smaller, or the list is empty, I have to do
Add
insert.
first.
So if n is smaller, right, than head, than current head. Correct? So we can put these two under one same if, right? So let's start doing that. Have a method that always adds nodes in a sorted fashion. So here we say if
You can create the temp after them.
if it's empty,
Isn't
Right.
n, if n is empty?
what is empty? Can a node be empty?
Yeah.
empty. I'm calling is empty. That is a method from the linked list. And it's a linked list, right? I'm calling here. Okay? If the linked list is empty, or like you told me, the current node that the data is less or equal to the head that the data, right?
Right.
Or the data at the head is bigger or equal to my element I want to insert, then forget about everything, just do it first. Correct? This one here. Else, do something else. Correct? Is this clear, guys?
Yep.
Yes? Now, can I inverse the two conditions? Does it matter if I inverse them? Does it really matter?
No.
Okay. Again, this is a question from Java 1 again. This is the second time I asked this question in this class. If I inverse them,
Oh, you mean
it will
verse
check
to
first.
the test expression?
Yes, it does.
Yeah, it matters.
It does
matters, right?
Yeah.
It will check for the node, get data, but if the list is null, do you have a head?
No.
You don't have a
It's
head.
better to have that one first.
So you're going to try to do null, which is your head, that get data to compare against the data from n. That will be a non-pointer exception, right? So you cannot inverse them. You have to watch out. That's why I put them in that order. Okay? You're going to check this second part of your only if the first part is not true, meaning only if your list is not empty. Therefore, it makes sense to talk about a head, right? Otherwise, it doesn't make sense to talk about a head. Is that clear? Yes? Okay. So, we have done these two portions, right? Now we have this number 3 and number 4. Number 3 and number 4 mean are the possibilities of inserting somewhere in the middle or at the end. Right? Correct? So these two guys are covered already. So now this is our problem, right?
Yeah.
Are there any other options? No. It just has beginning end in the middle and leaving end. There is nothing else. Now, which one shall we do first?
The last
We should do actually in the middle, because by trying to insert it somewhere in the middle, maybe our code will already handle this. Okay? That's how it normally works. So, now, how the heck do I insert it somewhere in the middle?
You need a temp, right? You use the sort by.
So, recapitulating a little bit. These two were easy, right? I want to insert something in a sorted manner. I have this node n. If the current node is smaller than this, let's say these were 6 instead, right? Or that these were empty, easy. Do it first. So it goes at the head, right? Now the problem is, what if I have to insert somewhere in the middle, like say 14? It has to go somewhere here, right?
Yeah.
So one option is to start moving and finding the right position, right? That's what we have to do, right? So somebody might say, okay, I know how to do that. I'll play with a temp, put it equal to my head, and keep moving. So if I put a temp, and I ask, are you bigger than this? No. So move. This is temp now. Are you bigger than this? No. Then you move here. Are you bigger than this? Yes. Now temp is here. How the heck do you go back to connect 14? You're screwed. You're screwed, right? You understand the problem?
Yeah.
Yes?
Great.
All of you?
Yep.
So, two possibilities here.
Can we create another temp?
One option is what Carlos said at the beginning, which means looking ahead. Okay? One option is looking ahead. Looking ahead means that I'm going to put them here, but I'm not going to compare this guy against this guy. What I'm going to say is your next bigger than this? If the next is bigger than this,
And compare.
then you know that you have to insert it already. If not, 12 is not bigger than this, right? I'll move them here. But I will not compare 12. I will compare the next of 12. Got it? Is 19 bigger than 14? Yes. So now I'm on the right temp. I can make the connections. Is that clear?
Yeah.
That's one way of doing the connections. Okay? Now, do we have a problem with that? Does that bring a problem? That seems easy, right? That's one solution. And we are lucky that we covered this already. Because if we wouldn't have covered that, we would be wondering, what if the number has to go before 7? And then we get in trouble. That's one solution, right? Another solution, instead of looking ahead, is having two temps. Temp 0 and temp 1, for example, or temp 1 and temp 2. So you would initialize your temp 0 to no and temp 1 to head. And they move like that. Got it? You compare temp 1, if it's bigger than this, no, then move temp 1 and make temp 0 be the old temp 1. Got it? So at the end, you will discover that temp 1 is larger here, and you have temp 0 to make that connection. Which one do you want to do?
Do the first one, would it be a problem if it reaches the end, because it's not your objective?
Just add to the end.
It'll look to has next, and there's no has next.
Okay, let's try to do the code right here.
You can just check for.
Let's try to do the code right here, okay? What would it be? I'll make temp equal to head. Both codes work. They need to do some adjustments, but both work. Temp equal head, right? And then we said we're going to keep moving. Well, temp, that get data, that get next, right? That get data is smaller than and that get data. Got it? Well, the data of the next guy from temp is smaller than the number I want to insert, means I have to move. Is that clear?
Yep.
Yes?
Yep.
Joel, is that clear? Okay. If that's the case, then I need to move. Temp will be equal to temp that get next. Right? Assuming this scheme works, I'm here, temp, I'm asking, temp that get data. Sorry, temp that get next that get data, 12. Are you larger than this? No, you're small. Since you're smaller, keep moving. This is temp. Now, the loop goes and says, temp that get next, that get data, 19. Smaller than 14? No, so I cannot move anymore. I escape my while when temp is here. Right? So what am I left to do?
So what if like end is?
Hold on 1 second. Let's first try to solve this, and then we're going to see the possible problems.
Okay.
So I have to make these two connections and break that one, right? That's what we have to do, right? Breaking this is not really breaking, because by changing this one, this is going to be broken automatically, right? The question is, shall I do this first, and then this? Or vice versa? Let's see.
Thank you.
What if I want to do one first? What would I say? Here. This is temp, right?
Right.
Temp that said next what?
To end.
To end. Right? And what do we do next?
And end that's.
And then end, just to make it that, right? That says next.
You don't know what
You don't
the
know
next
where
one
that is. You're broken.
Well, can you put
The no.
temp?
The old. So you
Oh,
gotta
no,
go the
no,
other
no.
one.
You gotta do two
The
You
first.
understand what happens, right? You
Yeah.
understand what happens, right?
Yeah.
I'm saying temp is here. I'm saying temp that said next. End. Right? I'm building link 1. How the heck do I build link 2? N that said next should point to this guy. But what is this guy? I no longer know what this guy is.
It would be no.
Got it? I'm screwed. Right?
So you need a second one.
So this way does not work. I should do this second, and I should do this guy first. Because now what I do is simple. N that said next, what? N that said next is temp that get next, right?
Right.
And then
Snap cut, get next.
Set.
temp that said next.
And
Got it? Is that clear? You have a question, Carlos?
I was just saying, if the n is bigger,
If the N is bigger,
if n is like a bigger number, you
like
have-
40.
yeah. then
That's
you-
that's analyzing what happens if it's at the end. If it should go at the end.
Right.
Okay? Let's see what happens if N were 40. Let's see if our logic still stands. Now, Carlos is saying, what if instead of inserting 14, I want to insert say a node with 40? It should go at the very end, right?
value of temp is null,
Has to be
and then you just insert it there at the end.
So he's saying, analyzing the last value
So
of temp is null.
it doesn't give you an exception.
Yeah. Can you just in the while loop put and temp dot get next doesn't equal null?
And
Like in the while, you have and temp dot get next doesn't equal null.
okay, he's trying to make sure that you check for the get next from temp. If it's not null, it makes sense check. And if it's not, then you break the loop. So you would end up with temp here.
Oh, yeah, then you,
Let's see what happens.
you lose 40, don't you?
No, you don't lose 40. 40 is still in end. Do you understand what Carlos is saying?
Yeah.
Carlos is saying keep moving temp as long as the next is smaller than the number you want to insert, or your temp has reached the last position. Right? I'm just denying the condition. That's why I'm telling like that. Got it? So you only move when this guy is smaller or when there is something else to do. Right? Okay. Let's say that works. And I'll put a condition. I'll just have to put here and then that get next is different from now. Let's just add one more condition. Pretty much saying move as long as your next is bigger, or sorry, and there is an x. Otherwise I cannot move. Right? Now let's analyze. If I have temp here,
You have to ask it first.
that's fine. Let's see what happens. I would end up with temp here, right? If it's 40, right? And I would try to say and that set next, temp that get next. I would say and that set next. So now we're analyzing a 40, right? 40 should go here, right? This is temp, right? And here is I have my end that should go here, right? Initially no. Correct? This is end with 40, for example. This is end, right? Now we have gotten out of the while loop. Not because of this condition, but because of the condition in red, right? Correct? The next is already no, right?
Yep.
And I'm saying that I'm going to do the two black lines here. The first black line says, end that set next, end that set next, temp that get next. Get next was no, because I got out because of that reason.
So then n would now be no.
So I'm putting no, I'm putting the next of end to no, which is fine.
It was already null.
It was already no, I'm just putting no again. Doesn't really matter. And that's fine to be no, because that will be the last no. Correct? Then this line is saying temp that set next, end. Temp that set next, end. Good? Works? Got it? That's why I told you, let's do the one inserting in the middle, and maybe doing some little patches at the end, we can get the other one, which is just this condition in red. Is that clear? Yes?
Like I was saying before, instead of doing the and, you do an or. So if it is null, then you just still do it and you don't exit the loop, like Carlos was saying.
You could do a conditional. You could do, that would be, okay. You're saying at the beginning ask, is the next of the temp null, something like that?
Yeah, so within the while, after the first condition, you do or, the next is null. Because if it's null, then it should.
Remember, when you put in the condition is what you want to, what you want to be true for it to keep going.
Oh, okay.
That's why I'm putting the denial of that, which is not null.
Okay, yeah.
You got it, right? Clayton?
Yeah.
Okay, so what I will do here is just say, do this, no temp, equal head. And pretty much say, well, temp that get next. That get data, right? Well, the next that get data is smaller. You can say it's smaller or equal, doesn't really matter. Than n that get data. Means you have to keep moving, right? And that get next. Different from no, otherwise I cannot keep moving, right? When that's the case, well, the next of your current temp is smaller than the one you want to insert, that means you have to keep moving, right? You find one get next that is larger, right? So temp equals temp that get next. Correct? And finally, you do the two lines in black. And that's it next. Temp that get next. code good? Yes? You like it? What do you say? What do you say? Is it good?
Mm-hmm.
You were the only one that said it's good, man. This code is wrong, guys.
Wrong.
You know why? How the heck am I going to check for get next if I can't check that the get next
Yeah, you
is
should
equal to no?
switch them. So you put the, put that to the end.
It's something you should tell me before I ask. Okay, so you are messing it up.
I was trying. Before you told me to.
Now it's fine. Got it? Now, what happens if the linked list has just one node? Does it still work? Sometimes those cases are also crazy. If my linked list just has one node, let's say 9, and I want to insert 12. This will be 10, right? 10 that get next is null, right? So the while just breaks, doesn't even get in, right? And you do these two lines. N, this is N, that's set next, to 10 that get next, pointing both to null, doesn't really matter. 10 that's set next to N. Works. What if it had to go at the beginning? Well, you already covered that for being smaller, right? So our code works for all cases. Is this clear? Yes?
So set next looks for the next one and get next puts it actually in there.
The other way around. Set sets, you know,
Puts it in
changes.
and get, you just check.
You just
You compare
obtain it.
the n with the 10.
Correct. The get is it obtains. Get is obtained. Give me the one that is there, that is next to you. Set is change the one that is next to you.
Oh, change.
Imagine you are pointing with your right arm, and I tell you, get next. You will give me the one that is, you will tell me you can. Got it? But if I tell you set next, and I say Chelsea's, that would mean that I will have to make Chelsea's place instead of Lucan's place. Got it? That's changing something.
Change.
Don't you need the size plus plus?
Where? Here?
For that, no, not there, because if you do that, then the first if statement already has it, but you need it at the else.
1 point for that place. Excellent. I have to put it here. Because if I put it at the bottom, I'm going to increment the size regardless. And the at first is already doing that. Right? How many of you understood this one? It was a little complex. How many of you understood this one? How many did not? Raise your hands. Only 3 people? Really? The rest of you understood it? Awesome? 4, 5, 6, now it's growing. I will explain it again because I know this is not that trivial. Okay? Okay. Very quick, okay guys, because I need to get done with linked list today and start stacks and queues. So, this is a linked list that is sorted. All the nodes are sorted. Okay? And I want to add one node. The node has to be inserted in order as well. So if I say insert 9, it has to go between 7 and 12. If I tell you insert, say, 2, it should come here. If I tell you insert 22, it should go here. Is that clear? So there are 4 possible scenarios we have identified. First, that I have to insert it here at the beginning, maybe in the middle, and maybe at the end. Another option is, what if the linked list is totally empty? Right? Where should I insert it? At the beginning or at the end is the same thing. So we choose say at first. Doesn't really matter, right? Okay, we're going to combine 2 scenarios. Scenario 1 and 2, which were, if the linked list is empty, just add the node at first. Right? That will be my head. Scenario number 2, if the node that has to be inserted is smaller than the head, it has to be the new head, right? And that is easily achieved by calling our add first from Monday, right? So that's what I said there. If you read the logic, it says, if the list is empty, or the node you want to insert is already smaller to the current head, then that node should be added at first. Done. Is that clear? Yes? Else. Else means it has to be inserted somewhere in the middle. Okay? Like, for example, we said 14. This is node n. Right? So what I'm going to do is, I'm going to put temp here, I know already for a fact that the node that I want to insert in will not go before 7. Why? Because that has already been checked in the if. It has to go after 7 in the worst case, or even farther away. Is that clear? So, I need to ask if it has to go between 7 and 12. How do I know that? I will say temp that get next. Temp that get next is 12. And ask the next of temp if he is larger than the one I want to insert. If he's larger, then I don't need to move temp. I just need to connect the current temp to this guy and this guy here. Right? But in this case, for example, 12 is not larger than this. So I need to move temp and make temp now. This is my new temp now. Got it? And repeat the operation. Right? Is your get next, right, larger than this one? Yes. Then I don't need to keep moving. I just stop. Correct? This is my temp now. Right? I didn't move. What do I do now? I need to do these two connections. This guy and this guy. Pretty much changing the next of the temp and changing the next of n. Right? I have to do set next for this guy and for this guy. Which one should I do first? If we do 1 and then 2, we have the problem. We say n that set next, sorry, temp that set next to n. Good, we made this link. How do I make this link? Should be n that set next. To what? How do I identify this node? I can no longer access this node. Got it? So what I do is make 2 first and then make 1. Right? I do this guy first. N that set next is temp that get next. Temp that get next. Good. This link is made. Now I just need this link. That is temp, right? That set next to what? To n. Done. Got it? Now, the problem that Carlos identified was this one. What if I want to insert, say, 40? So I will arrive, I was here, remember checking, are your next bigger than 14? No, so you move, this is temp. Do you have a get next here? No. So if you call that get next, this is going to crash because this current temp doesn't have a get next. So you have to stop here because there is nothing else. So I'm going to say, if you have a number that is smaller, and that number obviously has to exist, right? Then move. Otherwise, don't. That's what I'm saying. You have to, before moving, check that you have a get next. And the other condition is that the get next that you have is smaller. Then move. Otherwise, you cannot move. You have to stop where you are. Got it? That's why I added the no. So with that extra no, I'm going to stop here. Right? And I'm going to apply these 2 lines again and see if that works. And that set next, right? Temp that get next. Temp that get next is no. So pretty much I'm saying to your current n, let's say I want to add 40, just to show you that scenario. I want to add 40, right? That's what I said, right? Yeah. And this guy is pointing to no, and obviously this guy is pointing to no. It's the last one, right? I'm saying n that set next, temp that get next. Temp that get next is no. So I'm putting no again. Does that affect anything? No. Temp that set next to n. Temp that set next to n. Got it. And that's it. Is that clear? Better?
If you have one node and it's already pointing to no, then when you try to put anything in, it's not going to go in, right? Because they already have one that's pointing a node and you have no dot yet next.
If you have a node that is pointing his next to null, and you put set next to null again, you're doing nothing. If you have x equal 5, and then somewhere below you say x equal 5. You're doing nothing, putting a 5 again on the same variable. Got it? The node n, initially when it's received, has an x that is null. When you're saying this line and temp that get next is null, pretty much you're saying put your next to null. It's already null. Nothing. You're not doing anything. You're not affecting it. And it's correct to be null because it will be the last one. Right?
But then you can't enter anything in because it is the last, it's the first and the last, right? If you just have one node that's just it's the first, so it's the first and the last and it's already pointing to null, then when you try to put something else in, even though it's something that's bigger, it won't be able to go in because they're already pointing to null and there's already no dot.
You're assuming a linked list of size 1?
Yeah.
That's what you're saying? Okay, let's play with that. Say 7. What do you want to insert? This is null, and obviously this is the head, right?
Yeah.
What do you want to do?
Nine.
Insert 9. And this is no, right?
Yeah.
So the logic says temp equal head. This guy is temp. Right? The while loop says while temp that get next is different than no, temp that get next. Is it different than no? No, it's not. So the loop doesn't get in. So
You can't
temp
put it.
remains there.
Okay.
Temp doesn't move, temp remains there. Because the get next is not different than no, it's actually no. Got it? So you don't get inside the while. Then you do the 2 lines below and say n that set next to temp that get next. Put here whatever this guy has here. Same thing, doing nothing. And then you're saying temp that set next to n. Now you connected it. Got it? So it works. Is it clear for everybody?
Yes.
Yes? Yes? Okay, good. We can test it out. It wouldn't make much sense to insert numbers in a sorted way, because otherwise it will be the same thing as at last, right? So let's add the numbers in different order, and let's see if the linked list actually puts them in the right spots. Okay? I'm going to create a linked list, say linked list 3. And I'm just to play with it, I'm going to say add sorted, say 8. Say then I'm going to say add, oh, my bad. I have to put new node 8. And then I'm going to add, say 7, and then 12. Right? And then I'm going to print L3 that print linked list. If it's working as we expect, you should print 7, 8, 12, right? Got it? So it's working. Got it? So every time, if you use add sorted all the time on this linked list L3, it will always be sorted. If you do add last or add first on L3, you're going to mess it up. Right? Is this clear? Okay, last method on linked list. How to remove. I'm going to give you a note and you're going to remove it. How will I remove it? I will check if the note is there. If the note is there, I will take it out. Okay? Got it? If it's not there, I will simply put a message. I cannot remove it, whatever you want. Okay? So what do I have to do first? Okay. Possible scenarios. If this is empty. If this is empty, you show a message. You cannot remove anything. Doesn't make sense. Another possible scenario. Right?
Removing the first node, the head.
Removing head. Somebody else, right?
Okay.
If you remove the head, somebody else. Okay? Okay. And it's tricky because sometimes you want to remove a node, and this node might be the last node in the linked list. Removing the head doesn't necessarily mean that you are removing, you're making the linked list empty. You know that, right? Because then there might be more. You just have to update the head, right? But if you have just one element and you remove it, now things change. Your list is empty now, right? So what should we do first? Let's play with the simplest scenario, and then we try to fetch our case. Imagine we have a linked list like that, and we want to remove 12. Okay? Somebody tells me a node, 12. This is a node you want to remove. So I'm going to have to keep going and compare, right? Do we have a similar problem as before? If I find that this is temp, right? If I find that this is temp, how do I remove it? Because I have to say, removing 12 pretty much says that the one previous to this guy has to make this connection now. Right?
Replace it with something else?
You don't have to replace it. This is a nice thing from Java. Remember garbage collection from Java 1? Okay, you don't remember anything from Java 1. Okay, but there is a mechanism from Java 1 called garbage collection. Okay? Pretty much the way it works is when it finds an object that is being unused, it simply deletes that from memory. Right? You were supposed to learn that in Java 1. So, what happens? When I make the connection from here to here, Java is going to detect that this node is no longer referenced by anybody, and therefore release that memory for us. So we don't have to do that. All we have to do is change the reference from this guy to next for this guy. Got it? Now, if we go with the temp, and keep moving with temp, we're going to identify the guy here, right? But how do we move to the previous guy so that he can connect with the last? Let's keep that one.
While you're traversing, doing a temp get next.
So it would be useful to do something like before, right?
Yeah. So when you find that get next matches what you want, can you just do temp.set next, and then within that set next you say the set
Temp.get next.
or temp.get next.
And that's it. That get next, that get next.
Yeah.
And then you got it, right? Okay. So Clayton is trying to say you have to look ahead, because if you're here and you discover that your next is the one you want to delete, then it's easy to make the connection, right? So that's what I'm going to do. But what happens if the element I want to remove is 7? Let's try to solve first with 12, and then we're going to see what happens to that. So we'll do something similar than here, right? What do we do here?
You don't want to temp to the next.
This loop pretty much would tell me what?
You could take off
I cannot say this very good. Put something
the
different.
less than to just equal.
Equal, right? So pretty much I'm saying, well, you have a next, right? And your next, sorry. Right? Well, you have a next, and your next is not equal to what I'm looking for. Keep moving, because I haven't found the one you want to remove yet. Is that clear?
Yeah.
Yes? So when I get out of that loop, it can be for 2 reasons. What are these 2 reasons? Either temp contains the guy you want to delete. Sorry, temp.getNext contains the one you want to delete because this condition became false. Right? Is that clear? Either temp.getNext contains the one you want to delete because this condition is false, or temp.getNext is null. Therefore, you finished the whole linked list and you never found the one you wanted to delete, which is the case if I ask you to delete 47. Get next what you want to delete? No. Get next what you want to delete? No. Then, right? You would end up with 10 here, right? Correct? So what do we do now? I have to ask, right? Correct? How do I know that I didn't found it? How do I know that the element was not there? If I went out because of the condition. If temp.getNext is already null, that means I finished and I never found it. Right? Hold on 1 second. Element, no, else, I found the element, that element is indeed temp. Right? So what do we do now? This is the element. This is temp. Right? So if this is temp, this is the one I want to delete. Right? You understand that, right? Because it's always the next, right? If this is temp, this is the one I want to delete. You understand that, right? Okay. all I have to say is
Big
temp,
sentence.
that's set next, temp, that's get next, that's get next. Pretty much just skip one. Is that clear?
Yep.
Is that clear?
Yeah.
I'll show you what I mean now. So pretty much I'm saying, say that one I want to delete is 12. So I'm here on temp, and I will stop right here because my next is what I want to delete. So I'm saying temp that set next, temp that get next, temp that get next. Got it?
But what if you wanted to delete number 7?
Correct. Now my problem is that this works flawlessly if I want to delete any elements but the first one. If I want to delete the first one, it's pretty much what you guys told me. You want to delete the head. Right?
It's the first check deletes the data of the head.
So what do?
First thing you just check is that.
If the element I want to remove is the head, I have to update the head, right? Is that hard? If head that get data is equal to the element you want to delete,
And we
Then?
get head dot get next.
your head should be the head that gets next. Right? Else you have to do all this jump. That clear, guys?
Yep.
Regardless, right? Easy?
Why does head equal head dot get next?
Because if your element you want to delete is the head, your head should be now the next guy.
Got it.
Right?
So you deleted 12 because you went from 7 to 19?
Correct. I said this guy, then set next to what? To what was the next of my next.
Oh, 7 to 19.
Correct.
So temp is now 19.
No, then that set next. This pointer is no longer here, now it's here. I pretty much built this link, the link. I broke this and I built this one.
So you moved it, so what is deleted?
So this guy is no longer connected to anybody. 12 is not nobody connects to him. Got it? Nobody connects to 12.
Where's 7 then? 7 moved?
Nothing is moved. Okay.
But where did 7 go?
You have 7, you have 12, and you have 19. You want to remove 12. So this is 10. Okay? I stop right here because my next is what I want to delete. So I'm saying temp that's set next, put there, then get next of his get next, which will be this guy.
19 here.
So I'm breaking this link and I'm putting it here. So the linked list looks like this now. The linked list looks like this now. Got it? Is that clear, that link?
Yeah, so what happens to 7? It's not connected to the list, that's the only thing that.
7 is connected to 19, it's connected to the list. This
Oh, it's
continues,
connected, okay.
this continues being the head and everything.
It just moved.
I just moved his next. Look, this arrow is coming from here.
I guess I'm confused because I don't know where the number 7 goes.
That's the data. Remember, the node has two portions, data and next.
So you have 7, 19. and
Put it
12.
this way. Say I want to delete you from the linked list and you can is 10, okay?
Yeah.
You're like 12 and you can is like 7, okay? You can has his right arm on your shoulder and you have your arm on your on JD on Sadie's shoulder.
Right.
Now, what I'm gonna do is, if I want to take you out from the linked list, since I know he's the head all the time, all I need to know is, all I need to have him is be connected to Sadie's, have his arm on top of Sadie's shoulder, so that next time I look for the linked list and I want to print the elements, I will go to the head and tell him who's next. His arm is on Sadie's shoulder. He will skip you and say Sadie's is the next element. Even though you are still connected to Sadie's, right?
Right.
Doesn't really matter. I
Okay.
ignore you. When I want to print the linked list, I will find from him. I will move to her. I will not be able to find you from the head.
And Java deletes the middle thing, right?
Sorry?
And Java deletes the middle thing, or it
And Java's
erases
going
it.
to delete you afterwards through the garbage collection because he's going to find that nobody's referencing, nobody's connecting to you so far. It's going to disappear.
Thank you.
Got it? So that's the idea.
Where you have size, wouldn't it decrement even if element is not found?
Good question. Good question. Is the right position for size minus minus? Obviously not, because if the element was not found, you're still incrementing size. Good. 1 point for you, man. Here is when I delete the element, right? Correct?
Yeah.
And where else? Here, right? The remove is the most complex one of all. But it's not really that hard. Was it that hard? Not really, right? Now, is there another way to do it? Yes. You can make up a million other methods for linked list. Things I suggest you to practice because I might ask in the exam. Giving a linked list and a node, like the method remove, that you get a node. What if I tell you, give me the index of? Remember index of in array lists? Tells you the position where the element is, and if the element is not there, returns what? -1, right? So to give you a node and tell you, give me the index of this node in the linked list. So what you would have to do is go from the head and increment the counter. If you finish the whole thing, then you return -1, right? Correct? If you found it somewhere, you return the position. Is that clear? Okay?
Does that position start at 0 or 1?
Sorry?
Or link the position?
You will start with 0. Let's start with 0 to be compatible with arrays and arrays. It's our implementation, remember. You can do whatever you want, but let's start with 0. Now, why is that method useful? Back in the day, when I had more time, I would code that for you, which is very simple. Nice, like 3 lines of code. But why is that useful? Because the remove could get simplified. Before removing an element, inside that method, I could ask, give me the index of this element. If it tells me -1, just return element not found. If it returns me something different from -1, I would look up to one position before and do the connections. That's it. Got it? Is that clear? Yeah. So you know what to do for the weekend, right? Find the position of an element in the linked list and remove the element from the linked list using that method in there. So you remove, call it remove 2 if you want to. Should look a little different from this, but should work the same. Is that clear? The second one is, now that you have this method called index of that returns an integer, right? Create your method remove 2 that will use that method to find the element to remove and remove. Or simply say I cannot remove. Like I'm telling you, the logic is very simple. Before doing anything in that method remove 2, you would call index of in a variable, say pos, right? If pos is negative, then you just print a message saying element not found, cannot delete anything, right? Else means that the element is actually there. All you have to do is look up to one position less than that, so that your temp is one before, and you can now do connections. Got it? How hard is that? If your position is 0, head equals head that get next. That's the element you want to delete. Else, loop one before, and just do connections. Like I'm even giving you the pseudocode already, guys. Right?
It could be any number, we just make our own.
Yeah, put any element. It doesn't really matter. Remember, for removing, you don't have to be sorted, right, darling? It doesn't have to be sorted. You can remove any element from anywhere.
Doesn't matter which number we remove.
Doesn't matter. Now, this logic removes the first occurrence of a node. Okay? Guys, remember, this method removes the first occurrence of a node. So if I have, for example, 12 and 12,